Hi, this is Lori, and welcome to episode 3 on the Pico W. Today we're going to hook up an external LED and use it to blink Morse code. We'll have two levels of this project where we'll do a very simple micropython program to blink Morse code, and then we're going to create a more complex program that'll handle anything we want to input and put it out as Morse code. So let's get started. So to lay out our circuit, we're going to use a breadboard. And a breadboard is a device we can use for prototyping our circuits along with our microcontroller. So we're going to use this to place our microcontroller onto this board and be able to connect up all our electronic components. So it's important to understand how it works. So let's start at the top here. You can see there's a couple of rows that are labeled with a positive and a negative. And these rows are connected to each other, but along the line, but they're not connected up and down. So the negative is separated from the positive row. And we'll use this for creating power and ground rails. And you can see we have another set of those at the bottom. The interior here is where we'll connect up our components to the Pico. So we're going to place our Pico on here, and we're going to place our other components. And these are connected in rows. So these 5 input points are all connected to each other, but if you go one row over or one row back, they're not connected. So that's what these green arrows are trying to tell us. And then you can see that there's sort of this divide on the breadboard. Nothing connects across that divide, so the top and the bottom are separated from each other. Now, I found it easier to remember all this once I opened up a breadboard to see what it really looked like inside. And you can see that here's the rails, for example, and you can see that the top and bottom part of the rails, that positive and negative, all are connected, but they're not connected to each other. And you can see the interior pieces here, the little 5 input points, are all connected but not connected as we move over or back. And here's the divide, and so that separates the top from the bottom. So that's kind of how it works, and I found it helpful to see what it really looked like on the inside. I actually pulled out one of these little metal pieces just to take a look at what it looked like, and you can see here's the places that we'll plug in our components. There's 5 of them, and that they're all connected. So that's how the breadboard works. So here's a diagram of the circuit we're going to create to put in an external LED. So we're going to place the Pico onto our breadboard, and we're going to come here, and using the pinout diagram that we looked at before, we're going to find a ground, and there happens to be one 3 down. So I'm going to take and connect this pin here to the ground rail, so that negative rail, and make that entire rail now a ground. So that's step 1. Then we're going to connect this LED up to GP15, which happens to be the last pin on this side. So that's this little wire here is going to make that connection for us. And then we're going to put in our LED with the positive side connected to that new connection, GP15. And then the negative side of the LED, we're going to connect into a current limiting resistor, and then connect that last leg of the resistor back to ground, and that'll complete our circuit. Now we're going to talk a little bit about this resistor. The one I have shown here is a 220 ohm resistor, but how do we know what resistor to put in? We'll go through some of those calculations to see how people choose those. So here are all the components we need to make that circuit. We have our Pico, we have some connecting wires, we have our resistor, and our LED. So we're going to first put in our Pico. I'm going to push it all the way to the top here of the breadboard. I'm going to space it evenly across the divide so that we have places to connect to both sides of this microcontroller. So let's push it in, and sometimes you have to give it a good push to get it in. And you want to do it carefully, and you want to do it kind of as level as you can so you don't bend any of the pins. Next thing we're going to do is connect up our ground that we talked about. So I'm going to count down to the 3rd pin, and I'm going to connect it up so that I have a negative rail. So there we go. Now I've made the negative rail, so it's ground all the way along on this minus row. The next thing we're going to do is connect up to GP15. So we're going to put our little wire in. So I'm going to come down to the last pin and push that in. And now it's time to put in the LED. And you can see we talked about the positive and negative. How do you know? Well, usually the positive has a longer leg and the shorter leg is the negative. So we're going to put the positive towards our GP15 and push it in, making sure our negative gets on a different row so they're not interconnected. So we'll do that. And then here's our resistor that we're going to connect in. So we're going to put it so that it goes in the same row as the negative side of the LED. And then this row needs to come back and be connected to ground. So there we go. We got our circuit all put together. So how do we know what resistor to use? I used a 220 ohm resistor in this circuit, but how do we know what is the right one to use? So we're going to use Ohm's law, which tells us that voltage equals current times resistance, or sometimes it's symbolized this way. And here's our circuit that we're actually using. So this is sort of the engineering drawing of the circuit. So here's our pin that's going to provide the voltage, and the current's going this way. Here is our LED, that's the symbol for an LED, and then here's our resistor, and it comes back to ground. So that's the circuit we're using, and Ohm's law tells us that we should be able to figure out the resistance if we know the voltage and the current. So if we turn the equation around to solve for resistance, we need to look at the voltage. So the voltage is going to be the supplied voltage from our Pico, but also how much voltage the LED kind of uses up. So it's easy to know the voltage from the Pico, that's 3.3 volts. But this, how much does the LED use up, that's called the voltage drop, and it's something that is a property of the LED, and it's called the forward voltage of the LED. And you kind of have to look around. These LEDs don't necessarily come with data sheets for you to look up. They're very cheap, and who knows who made the ones in your kit. But I did find in the SunFounder tutorial, which was the kit that I got my LED out of, that they said the forward voltage of the red, yellow, and green LEDs is 1.8 volts, and then the white ones are 2.6. The other nice piece of information that was in this tutorial was that it can withstand a maximum current of 20 milliamps. And we'll also need that too, because that's the current for the circuit. So that's how I knew that the voltage drop, or the forward voltage of this LED, is 1.8 volts, and that the max current should be no more than 20 milliamps. So now we can use that information, plug it in, and do the calculation, and we'll see that we need 75 ohms. So that's a lot less than the 220 ohms, and I think the reasoning by that is that these LEDs are pretty bright, so you don't need it to be a super bright, so you can up the resistance a little to kind of tone it down a little. And I think it'll also extend the life if you use a little bit more resistance than what you calculate here. This is the program we're going to use to blink the red LED. It'll give us a chance to test and see if our circuit is all hooked up correctly. It's very similar to the program we use for the internal LED. We're going to import the pin function from machine library, sleep from uTime. We're going to set up the LED at pin number 15 as an output, and then in our while true loop we'll toggle the LED on and off, sleeping in between for a second. Go ahead and run this, and hopefully, yes, we're seeing it blink. Very satisfying. So now it's time to blink some Morse code. So here's charts of Morse code for all the letters in the alphabet and the numbers. And you can see that, for example, the letter A is a dot and a dash. And this other version just shows it in a way that maybe you could remember it a little bit better, symbolizing the dot and the dash as a part of the letter A. So I thought they were both very interesting ways of showing the Morse code. And the other really important thing about Morse code is getting the timing right. So the dot is shorter than the dash, but how do you know how much time to take for each and how much time to take in between dots and dashes and in between letters and then in between words? So I put together a slide on that. So it's all based on the dot. So however long a dot takes, a dash is going to be 3 times that. And then here I have Hello Pico written out in Morse code. And then there's 3 more timings we need to keep in mind. Within a character, so an H is 4 dots. Within that, there needs to be the inter-character space timing, and that is 1 dot in between. And then when we go between characters, for example, we go between the E and the L, we need to space it in terms of timing of 3 dots. And then in between words, we need the timing of 7 dots. So that's how you set up all the timing, and that's going to be important for us as we flash our LED to create the dots and dashes. We're going to have to build in all those spaces as well. And then, how fast should a dot be? There's no specific number it has to be. It's all a matter of how fast you want to go. And this is an equation I got from morsecode.world website, and it's based on, well, how many words per minute sort of on average do you want, and then it'll tell you how long to make the dot, and then obviously you can do all the other timings based on the dot. So now it's time to do the beginner level of our Morse code Python programming. We're gonna flash SOS, just that, nothing else. So we'll set everything up just like we did before, and we'll need to calculate some timings to flash the SOS. How long will a dot be? How long will a dash be? And so forth. So I used that equation, and I picked 5 words per minute because it flashes pretty fast, and unless you're very good at Morse code, I think you'd rather go a little slower. So I tried 10, and I decided that 5 worked pretty good. So that's what I'm putting in. So a dot's going to take 0.24 seconds. And then everything else, the dash, the within character, and between character are all based on that. And we don't need between word because we're just going to flash SOS. So next, I'm going to take the LED and set it to off just so it's off from the start. And then in our while true loop, we're going to start blinking the SOS. So I printed that to the screen, decided to sleep for a couple seconds just so we could pay attention and have a space in between because it's going to keep looping the SOS over and over again. And now we're going to print the S. So the S is 3 dots. So we'll turn the LED on, sleep for a dot, turn the LED off. Then we're going to sleep for the within character time, which is also a dot. Then we're going to turn the LED back on, and you can see I used a different function this time to turn the LED on and turn the LED off. Works the same as the value, and maybe it's a little more clear what you're doing. We're going to sleep again and do the final dot, and then we're going to sleep the between character time. Then we'll get to the O, and that's 3 dashes. And so now we're going to turn it on and sleep for a dash, turn it off. Sleep toward the within character and go to the next dash and the next dash. And then we'll do the final S and get to the end, and then we'll say repeating, and we'll keep looping. So let's try this one out. There we go. All right. Dash, 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 dot, dot, dot. And it tells us where it's repeating. There we go. So, working pretty well. Honestly, wasn't good enough for me. I really wanted to, as a user of the program, be able to type in a message and have it blink out and be whatever message I wanted with words and numbers. And so I started thinking about how could I put together a Python program that would do that. And I realized this is going to get more complex. So if you're just beginning, maybe you want to skip this part of the video. Now, I also have the book called Programming the Pico from Simon Monk, and this is one of the examples that he works through to teach MicroPython, so I definitely recommend that book. I did get some inspiration from it, but I did program it slightly differently because I was very careful with the timing, a little bit more than I think Simon was in his book. So I might have went a little bit overboard, but I wanted it to be as correct as I understood how the timing for Morse code works. So let's get into the program. Same as before, setting up the LED, getting the libraries, setting up the timing, making sure the LED is off. And now we get to the first more advanced part of this program. We're going to use a dictionary to store all the code for the letters and the numbers. So you can see a dictionary is kind of a lookup table in Python. And so here's the A and here's the code for A. And they're all kind of matched up as pairs. So that's important because that's where we're going to go get the code we need as we try to print off these letters in Morse code, letters and numbers. Next, I created a function, which is also kind of a little bit more of an advanced topic. So it's going to be a function that I can call again and again. And this function is going to blink the LED for a particular letter or number. So I'm going to use this over and over again as we do larger messages beyond a single character. So this will be called routinely, and this is the workhorse of this program. So I've got it commented here, and you want to slow it down so you can pay attention and really understand what each step does. Feel free to do that, and I'm also going to share the code for this entire lesson on my GitHub page, which will be linked in the description. So we'll start off, and the first thing we'll take care of is sleeping between words. So if there's multiple words, we're going to sleep the proper amount of time for that. So it's saying if the character is a space, then we're going to sleep the between word time. Now I take off 3 because the way the rest of this program works, it automatically builds in 3 dots of sleeping at the end of each character. So I need to kind of take that off so that I don't sleep 10 dots instead of 7. So that's why I'm subtracting the 3 from there. Now, if it's not a space, then it must be another type of character. And so we're going to look that up in the dictionary. So this is the code to look that up. And then I'm using a function to make sure we just use the lowercase, because you saw in my dictionary, I only have the lowercase letters in there. So the user might type a capital letter, but I'll just automatically switch it to the lower. So that's what that piece of code does. And then if we find the code in the dictionary, because it's possible they might type in a character that we don't have Morse code for. So if we find it, then we're going to go ahead and print it to the screen and show the code for it. And then I need to know how long it is, because on the last part of a character, we need to do the proper sleeping. So we need to know when we're getting to the end of the character's dots and dashes. So I'll set up a little counter for that. So now we're going to loop through the code, and we're going to increment the counter, and we're going to check to see, is it a dot or a dash that we need to blink. And this is very similar kind of to the SOS, but we just need to check, are we at the end of the character's dots and dashes? Then we're going to sleep the between character amount of time, but if we're still got some more dots and dashes to do for that character, then we're just going to sleep the within character amount of time. So that's what this code here does, and we do that both for the dot and for the dash. Similar code. And then if somebody inputted a code that we don't have Morse code for, like an ampersand or an exclamation point, then we're going to print to the screen that we don't have Morse code for that character, and we'll print the character so they know we don't have a code for that. But it'll just keep going anyways. It'll just skip past that character and keep going. So that's the function that kind of drives this whole program. And that was pretty fast, so you might need to take some time to work through it. It certainly took me a while to think through how to get everything right. And then our while true loop is relatively short. We're going to input a message. The user's going to give a message, and I'm trying to clue in the user to use just the letters and numbers, that nothing else is going to work. And then we're going to loop through each character in the message and call our function that'll do the blinking for us. So that's it. Let's see it go. So now we can input our message. So I'm going to type I love the Pico, and I'm going to put an exclamation point at the end so we can see how the program works there. And you should start to see it flashing the codes, and it's also printing them on the screen at the same time. So it's going pretty slow because my old eyes don't see dots and dashes too well. Okay, we're getting close. We're on to the P, the I, the C, the O. And it tells us it can't do anything with that exclamation point. So it worked perfectly. I want to thank you for joining me. It was a blast putting together this final Morse code blinker program, and I hope you enjoyed it.